Hello my friends, it's Truax31 here. I'm a bit under the weather. I think I've got my third cold of this winter of hail that will not seem to leave. Looking out my window today, the snow's down to about 6 feet on my front lawn, but we're supposed to get another 4 or 5 inches this weekend. So it is after only April 10th, I think. But anyway, today I guess we've talked about heat loss, we've talked about floor temperatures, and we've talked about water temperatures, and today I want to talk a little bit more about water temperatures and specifically how the floor coverings you choose affect those water temperatures. Okay, so have a look at my drawing here today. I've set up a scenario where we have 4 identical rooms, each has identical heat load. So I want to show you how floor coverings affect that water temperature. So let's take a look at the first one. First one being linoleum. We have installed our tubing, as you can see, with heat transfer plates underneath in between the joists. So the first one being linoleum, we'll have our 3/4 inch subfloor. You'll have to lay a layer of K3 down to make that surface nice and smooth for the linoleum. So you have the subfloor, the K3, and the linoleum itself has a certain number of resistance. So you figure it out, you do the math, and we find out that we need a water temperature of 115 degrees Fahrenheit to meet the heat load in that room. Okay, so let's move on to the next one. Next room, bathroom perhaps. You may have ceramic tile in there. Generally that's installed on a cement board or straight to the subfloor. And by nature, ceramic tile is just a conductive material, so you can turn the water temperature down much lower and achieve that same number. So do the math on that one. Find out we need only 82 degree water to meet the heat load on the coldest day. Third room. Again, identical in every way other than floor covering. We're going to use hardwood. This might be the living room or a vast majority of the house. Again, you have your resistance for the subfloor. You have the resistance now of the hardwood is a little higher. We find out we require a water temperature of 127 degrees to heat the room now. And the last one, bedrooms. Maybe you want some plush carpet in there with underlay, and generally that's pretty thick. So we said 3/4 inch underlay or 5 inch underlay, 5/8 carpet. Come up with an R value of about 2 on that, so the water temperature in this case is 153 degrees. So you can see the floor covering can dramatically change the water temperature required. So the plumber comes in, sets up the system, tempers the water down to about 125 degrees as he's been told, and what happens? Well, these rooms aren't too far off. You might be alright, but this room, what's going to happen? Well, it's going to overheat, obviously. And then of course the bedrooms will never be hot enough. There's just no way you can meet that 25 BTUs per hour with 125 degree water. So, are you beat? No. There is ways around it, and that'll be the next lesson. How do I deal with varying water temperatures and meet my heat load demand? So, till next time, have a great day.